Hello and welcome back to our video tutorial series on how to use GreenScenario. Now that we have a good understanding of what individual components do and how to connect them together into a bigger network, let's look at one of the example workflows focusing on potable water savings. At the moment you can see that we are not saving any potable water and there's no rainwater reuse in the drawing. And to make that happen, we need to have at least a few components selected and connected together. So the crucial one is our storage component, which is represented by this curve, and it's a cistern. It has a depth, and it's situated below ground. But still, there is zero savings currently, and the reason for that is that there is no water flowing into that cistern, and because we want to have a reliable catchment area that provides us with clean, uncontaminated water, we only collect water from the rooftops. And then in the only building that we have in the drawing, when we look at its options, by default, it's set to not contribute to any storage elements. So we need to manually turn this on. And still this number hasn't changed. And the reason for that is, of course, now we have water that's being directed into our storage, but there is no elements using the water. So we also need to tell the software how many liters per square meter of this particular building do we want to use within this building. So we just introduce this via a slider, and we can see that immediately this number adjusts. And then you would need to make some calculations over here and then understand what kind of building type is that. Is it residential or commercial? It follows different usage patterns. And then how many people do I have over there? And per square meter of this particular building, how much water would I be using? And you would introduce this over here, and liters per square meter per day. And of course, because it's per area, then the bigger the building or the taller the building, the greater its area, then the greater the use. Another way of introducing water use, so if I just dial this down to 0, would be to have a green area. And it will be following some irrigation needs. And again, here, this is also liters per square meter. So if we were to introduce this some irrigation needs to this particular extensive park, it could also be irrigated using water intercepted into this cistern. This software is smart enough to understand that we shouldn't be irrigating every single day. It's only irrigating at summertime and only on days when it hasn't rained anyway. And of course we can combine both of these and then say, we have water use both for irrigation and in the building over here. And you can see that right now with our storage volume of 33 cubic meters, so this is how big the cistern is, we can save yearly 19 cubic meters per year, right? And so how can we increase that value? So there's a few ways of trying to address that. First is we could try and make the cistern bigger, so let's just make it deeper. And then now we've been saying that yearly actually we need to use 40 cubic meters in this building. This would be the total need for the residents of that building and the irrigation areas. And to cover or to cover this need with 100% of stormwater, we would need a storage tank of roughly 80 cubic meters. That's one way of increasing this. Another one would be to say, yeah, okay, but then because our roof over here is actually a green intensive roof, which means that the runoff coefficient of this roof is relatively low. So there is some water that gets intercepted and evaporated rather than it doesn't run off into our cistern. So if we were to change this to a conventional rooftop, we could see that maybe we could decrease the storage volume over here, and actually by a substantial amount, right? So almost half it to 40 cubic meters, and then we're reaching the same level of 40 cubic meters per year of savings. So let's go back to green intensive. You can see we can only save 22 a year with the same storage volume here. So conventional gets us all the way there. Extensive would be 2/3, and green intensive is the least, right? So you can already see that it's a little bit of a trade-off between which KPI am I trying to maximize against, because obviously an intensive green roof, it's much better in terms of biodiversity scores compared to the conventional one, or open space provision, or green factor score. If I was to turn it on, my modules, green factor 0.25 with intensive green roofs, and only 0.18 without them, right? So if I was to maximize against the green scores over here, then I would probably want to go with my intensive green roofs. But if I'm willing to maximize the potable water savings over here with keeping the investment cost to the minimum, then I would probably go with the conventional rooftop to maximize the runoff. Another thing to consider as well would be which event are we calculating this for. So our 40 cubic meters over here are calculated for this particular year, 2013, because we have our daily file connected. We can analyze different years and then see, for example, in a drier year, 2006, and the savings will be less. And let's try and find a more a humid year over here would probably require less storage volume to achieve the same numbers. So it's a balancing act, trying to find the best components over here, matching that. And also you could look at the economical aspect of the whole scenario and try to understand what are the investment costs associated with different measures and what are the potential savings calculated over here. They are in cubic meters per year, whereas here we translate these values into euros. And for that, under the data component, we're looking at the input over here. What is the potable water fee in euro per cubic meter? And then the lower this is, obviously the lower the savings, and the higher the fee per cubic meter, the higher the potential savings as well. And so as you see, it's a fine balancing act. There is no proper answer to the question how big should the component be. It's always depending on the context, and it's a very interesting exercise to also go with your clients or your colleagues to try to go through different scenarios. And you can obviously save these as individual scenarios and then jump between them. You could also set some of them as baseline and then compare the others against that. So I hope it clarifies it. Just to sum things up, to be able to perform this kind of calculation, you need to have a storage component in your drawing. You need to have a building component set to stormwater collection, yes, so that the runoff from its roof contributes to filling up the cistern. And you need to have at least one component that uses the water, so it's either a building or a green area component. And you also need to have a daily file selected and connected to your data component. And then from this, you also need to select a year that you're looking at. And then again, historically, for this particular location, we can look back till the 19th century, and you can also see what is the result of maybe there's some perceived results or effects of climate change on your particular location, like we can see here 2018 in Berlin that we're analyzing was an extremely dry year, and we'll be able to save only this much water compared to 2019, which is already contributing so much more.